This is an MCQ from kinematics, combined linear and rotary motion. So there is a hinge and there is a rod hinged at one end and free at the other end. It can extend freely at the other end, and this rod is rotated through an angle theta. So clearly the rod is having two types of motion. One is rotary motion and another one is linear motion. So it is extending due to its self weight and the centrifugal force and so on. So due to these effects, the length of the rod will increase. So clearly the rod is having two types of motion. One is rotary motion, another one is linear motion, radially outward. So the question is, what is the magnitude of the velocity, that is nothing but resultant velocity, at the other end of the rod? And what is given at time t? Lt, that is the length of the rod, is 1 meter, and L dot t, that is nothing but the linear velocity, that is the rate of increase of length, dl dt, is 1 meter per second, and linear displacement theta is pi by 4 radian, and theta dot, that is omega d theta dt, so that is the angular velocity, 1 rad per second. Okay, so let the rod has taken some time to displace this angle theta. Okay, so let us calculate the time taken for this displacement. Theta is equal to pi by 4. So clearly theta dot is given. Theta dot, that is nothing but d theta dt, is equal to 1 given, and theta is equal to pi by 4. If theta is equal to pi by 4, then what is the time taken? And clearly we can find out, if time taken to displace the rod from this initial position to pi by 4, theta is equal to pi by 4, is, let this is t1, then t1, what will be the value of t1? T1 is equal to theta by theta dot, because this is d theta dt, that means theta by t, that is equal to t, time. So pi by 4 by 1, that is equal to pi by 4 second. So in this time t1, so what is the increase in length? Let us calculate. Okay, so this is the increment. Okay, so what is the increase in length? Okay, let us calculate. So rate of increase in length is given 1 meter per second. Therefore the increase in length will be equal to L dot t, okay, L dot t into time taken to reach at this position, that is equal to t1. We have taken t1, so this is nothing but 1 meter per second into, this is pi by 4, so that is equal to pi by 4 meter. Okay, so this is the increase in length. Therefore what is the total length from the hinge to the outermost point? So what is the total length? So initial length was 1 meter. Therefore, the total length is equal to 1 plus pi by 4. Okay, this much of meter. Now we have to calculate at this other end. Other end means at this end. There will be two types of velocity. One is radially outward and another one is tangential. Okay, let this is VR and this is VT, tangential velocity. So VR is radially outward, that is nothing but 1. This is, so VR is equal to L dot T, that is equal to 1 meter per second, and this VT, tangential velocity VT will be equal to R omega. So what is omega? Omega is theta dot, and R means this length, this total length, that is nothing but this total length. Okay, so 1 plus pi by 4, this is the R at this position, and omega, that is nothing but theta dot, so that is 1. So 1 plus pi by 4, 1 plus pi by 4. Therefore, the resultant velocity, okay, resultant velocity will be equal to root under, see this is 90 degree, so only this one square VR square plus BT square, that is equal to root over of, VR means 1 square plus VT means 1 plus pi by 4 square, and 2 VR VT cos 90, this is 90 degrees, so cos 90 is 0, so another component is 0, so which is equal to, if we calculate, it will come near about 2.04 something. Okay, resultant velocity, this much of meter per second. Okay, so what are the options given? A 1 meter per second, B root 2 meter per second, C root 3 meter per second, and D 2 meter per second. So clearly it is matching with D, therefore the answer is D. Okay.